Today, I'm going to compare the data sources of starting an operational BIM project. I will detail the benefits and risks of importing an existing IFC file compared to surveying and inventorying a building by using OrthoGraph. In addition, I am also explaining how the professional CAD world can serve the demands of facility management compared to OrthoGraph. There are three main pillars of Operational BIM. Getting control of your building portfolio, create the as-built surveys and inventory of your buildings with ease, use simple and rugged tools like laser distance meters, RFID or barcode readers for that. We truly believe surveying a building and keeping its data updated is something that everybody should be capable to do. There should be no need to hire architects for doing it. Anyway, surveying and inventory is not something that they really love to do, but the regular maintenance crew must be able to do it. Easily, rapidly, and where things happen, right at the place of work. Maintenance people are the ones who really know the buildings and spend the most time there. The second pillar is about accessing the data from anywhere. Operational BIM only becomes valuable if decisions are made using it. If there is a significant cost saving by accessing it on site, for example for navigation, and if it becomes an integrated part of all building-related software systems, maybe more importantly, a deeply integrated part of all operational workflows. In addition to that, Operational BIM must become integrated with external systems too. External systems like CAFM or maintenance management software or BMS systems, anything that needs building data must be able to gather the measured and calculated information of the Operational BIM, as well as they should be made graphical by simple tools like a BIM web viewer. The third main pillar comes as a result of the second one. This is staying in control. If the Operational BIM is used to support the on-site work, to follow up moves, to access maintenance data, and when finished, to update all changes instantly where and when they happen, then all building knowledge will become centralized, stored in a central database accessed by anyone and anytime. What's the output of CAD systems? Let's see the relation of professional CAD systems to the Operational BIM. As their name says, they are computer-aided designing systems, not aimed for building operation. The big brands of this profession can be used for creating professional BIM for designing, construction, where they can generate a great value. They are also equipped with astonishing rendering functionality, so both technically and graphically many of them are capable of designing enterprise buildings with all their details. Some of them are capable to extract point clouds from laser scanning technology and then be used to model already existing buildings with very great details and accuracy. So data quality and accuracy is not a question in such systems. Let's see what they can do to do building operation and compare them to OrthoGraph's Operational BIM approach. CAD systems handle very detailed models with all building elements and technology built into them. For the operation, this might be impressive, but in real life, too much data means a large amount of work to keep it updated, and most of that is not really required for the everyday operations. We believe the optimal is the minimal required data, but not more. That makes BIM feasible for operation. CAD systems also need architects, highly dedicated people to maintain building models, done in the office and not where the changes happen. This means data loss, as to follow up every little change is difficult, but when they sum up, then we realize that the documentation becomes outdated. To handle BIM in highest details needs robust hardware that doesn't work on site. Typically viewing such detailed models is hard in a mobile device, but editing it on a small screen and low-power device is not achievable. Modeling an existing building, even if it's done from a point cloud, is a very time-consuming work done by professionals. All this sitting in an office in a distance from where things happen. On the other hand, CAD systems can create amazing renderings, which are a great value for seeing how a design building will look like. But that's not the world of Operational BIM, which is about effectiveness and understandability. What's the output of CAD systems? First of all, very detailed professional CAD documentations, great designs, for each building individually. The better systems like Revit or AutoCAD are following or even defining the concept of BIM, but they all lack of inventory, where assets are having their unique identifiers, barcodes or RFID tags. The main output is again, the beautiful renderings, mobile and web access to the models are not in focus, they are not instantly available for the models, but even if they exist, then only with a nice amount of preparation, rendering and publication. This is not the key goal of these systems, we should understand. The purpose of CAD systems is to make the best out of the designing something new or redesigning something existing for refurbishment or innovation. Building operation has never been a focus of these systems, and they are also nor good, neither feasible for such use. For construction, this level of detail, the quality of these designs are very well usable, so the better CAD systems are all supporting construction on different levels with digital data. Operating buildings, running graphical reports, or accessing data everywhere for editing by technicians have never been a goal of CAD systems. What does this mean? What's missing from the CAD system that is required for facility and maintenance management? These systems are file-based systems not built up in a database, so they don't operate in the cloud. CAD systems also need highly educated users to create and maintain building data. This also means whenever there is a new release of the system, then these people will be needed to be trained to use the CAD system even if there are no big changes on the buildings anymore, only the need of alignments for tenancy or other functional changes in them. CAD systems are robust. They need strong environment, big monitors in the office. It's never been a question for designers to work on small monitors or even on phones. This means when things happen on site, changes and repairs, maybe replacements are done. The registering them in CAD systems is only possible in the office after a long chain of communication, again by the highly educated architects. Supporting inventory, handling required fields, fixed value list, or freshly sticked RFID or barcode identifiers is not in the portfolio of CAD systems. They are simply not required for designing work, which is fully understandable. But the changes happening on site is done by the maintenance crew, maybe by additional people following up moves in the inventory, or the technicians of a production factory once rebuilding a production chain in line with new requests. All these changes are made by a big bunch of people at the same time right on site. Certainly, it wouldn't make any sense to store maintenance data, manuals, videos in a model made for planning and probably for construction, so that's also not available in CAD systems. CAD systems are not built on databases. Integration with external systems are mainly made on file basis or sometimes using built-in applets to the CAD systems, but ERP systems have never been a target of CAD systems. This also means that accessing data by the on-site worker communicating about exact elements of the BIM is not available. The same is true for opening elements by using, for example, RFID or barcode identifiers. CAD systems cannot help the work of maintenance crews on site with any live element. Though floor plans might contain everything in detail, graphical colorizing locations based on this information or based on information coming from a facility or maintenance management system is barely possible. And if it is on somewhat level available, then it always needs access to the BIM through the CAD application. Though data changes at the place of work, these changes can only be updated in the CAD BIM using the same CAD application as it was used for designing it. In the office, far from the place of work and by different people than the ones who made the changes. The highly educated people operating the CAD models, typically architects needing challenging goals regularly, these smart people love to practice their professions, create and design new ideas. Following up changes could not be further away from their dreams. This means high fluctuation, continuous training of new employees and continuous follow-up trainings of CAD system changes as they change in line with the demands of designers. Please note, designers again, not operators. I already mentioned that CAD systems are based on file communication and the BIM is also stored in files. In some situations, some modern CAD systems start to implement database technologies, but these are optimized again for graphical data management without serving those external systems that really need operational data, like calculated surfaces, report of changes, or a detailed asset inventory. Changes happen by many people crawling around the building. Maintenance people replace devices, movers move departments around, and sales people rent out different parts of the buildings. All these changes happen at once and the system must be capable to handle these many minor changes in the model. Neither the pricing model nor the technology of CAD systems have been developed in line with these requirements. And if there are changes and the building documentation becomes different during a period of time compared to its prior state, then accessing back to all these previous steps and changes is not possible in CAD systems. Let's see what do we get for facility and maintenance management from CAD systems in terms of long-term building operation. Creating models is time-consuming work of highly educated people. All this without inventory, far away from the site to be modeled. Models are not accessible for the maintenance crew, and for editing, it will not be there for even a long period of time from now too. Changes made in buildings cannot be followed up, only if there is a long, expensive and difficult chain of communication that somehow connects the place of changes with the office of architects who apply those changes on the BIM. As we see, Operational BIM is very different from the regular CAD services. It is not only the technology that has different requirements in these words, but the use and content of BIM has also many differences. Operational BIM should contain many more and typically very different data that is crucial for the operation than the regular BIM. Let's dive into the details. Let's see what we can achieve by reusing the BIM created by the architects of the building. First of all, yes, OrthoGraph is capable of importing existing IFC files. Majority of the content is imported in one simple step that produces a 3D BIM model in OrthoGraph. It contains walls, doors, windows, and all objects are also imported with all of the attached data available from the BIM. By default, objects are replaced with placeholders, keeping the original object's positions and dimensions. This means it's just a tap to import an IFC file into a new OrthoGraph project. As IFC files might already have some connections to external systems, so OrthoGraph retains these unique internal identifiers unchanged as long as it is possible. Once the model is available inside OrthoGraph, using the element properties, all objects, doors, windows can be bulk replaced by filtering on some of their properties. This means some manual work once the project is loaded, but well-manageable 3D models can easily be created by simple user work. It's important to mention that source IFC files need to be prepared properly to be supported. OrthoGraph's requirement is that every location to be imported should have location stamps in the source file. These location stamps will be reinterpreted in OrthoGraph to be locations, and OrthoGraph will search for their belonging walls. Finally, OrthoGraph connects the original wall data to the newly built model elements. So, if we can import an existing BIM design, what's the problem then? It's not a technical problem, rather a financial risk, and Operational BIM is rather a financial approach to the building than a designer's approach. First of all, the as-built building typically differs 5 to 10% from the design model. Please keep in mind that such an inaccuracy will produce a difference only on the rental fees during the 30 to 50 years of building operation that is comparable to the total construction cost of the building. And we didn't calculate the cleaning, operation and renovation costs that are also adding to this during the building's operation lifecycle. Designer BIM doesn't contain detailed asset inventory. Barcodes or RFIDs are crucial to build up effective controllable operation workflows, so that's something to be made up. Even if we have objects in the BIM, their data is rather supporting designing and construction, but not the operation. Operational information lacks from designer BIM, and that's logical. Much of that will become only available during construction when the building is realized. In our experiences, in most cases, floor planning takes 30% of time, the majority is spent on the graphical inventory. Later is required either the model is provided or if it's built from scratch. Just imagine how much work it is to stick barcodes or RFIDs on each maintenance point. There is also a critical loss if we start using a designer BIM. For surveying and inventorying, digital quality control should be provided by the surveying system, but when importing data, then it's not clear what needs to be revised and what not. So these quality controls are not available in such situations. CAD system, designer BIM certainly also doesn't contain real-life photos of built-in devices or locations. In many cases, devices are built in with irregularities as that's how it comes out during construction. Having this information even only as a photo can accelerate a lot on the maintenance work later. Finally, all the above typically results in remeasuring the whole building, which is typically more difficult than doing the survey from scratch. Certainly, the designer BIM will contain many details that if built as planned, then will provide great value and will be well usable during operation, so keeping such models should be stored in the CAFM system for future access. What benefits do we get if we survey and inventory the operational BIM from scratch? How can it be feasible? First of all, making a BIM of an existing building is not that time-consuming anymore. Just simply the surveyor draws in what they see into a mobile app and measures the minimum required number of walls using simple tools like laser distance meters, or at a refurbishment even a tape measure at hand can do the job. Once the walls are there and the rooms still need more details, then measuring diagonals will provide a very accurate floor plan. Once the floor plan is ready, then placing down and measuring doors is done with the same ease. Simply move your finger in the opening direction and measure the opening dimensions. This same applies for windows, resulting in a very detailed 3D BIM. Placing down objects and providing the properties will generate a very detailed asset inventory. OrthoGraph has a broad object library to support that, and it can also be expanded in case of such demand. In both cases, OrthoGraph's digital workflow control will ensure that all required measurements and asset data will be provided by the surveyors. In more difficult situations, a tripod-based measuring station can be used to capture floor plans and also to accurate position of required maintenance points. The result is the operational BIM ready for use that contains the detailed asset inventory and even attached photos or panoramic photos. Let's see, what more do we get by surveying and inventorying a building from scratch? First of all, reliable and fresh data. Surveys are processed within weeks, even in case of large buildings. In addition, the graphical asset inventory will also represent the current situation of the buildings that can easily be maintained by the regular maintenance crew. All drawings are captured with the digital quality control of OrthoGraph, resulting in high-quality building documentation, let it be a newly built or an already existing building. Barcoding or using RFID technology will provide the possibility to build up workflows by requiring the maintenance, cleaning, or security people to scan those data once they are at the required position. This also ensures that the proper maintenance points will be accessed, that results in high quality of work. What's always missing from the designer BIM are the real device photos. Capturing a photo of a fan coil taken apart and showing its specialties will provide information for the next repair to know what tools and materials should be brought to the work even before leaving the warehouse and going to the site. To optimize the building utilization, to be able to count with the available electric or air handling capacity, additional data recorded on site can be very valuable. And think about it, we are speaking about the overall productive performance of the building with optimizing building utilization. All this can be supported by real-life capture data. The existing building models, documentation if they are available, can also produce high value. Their data can be entered into the Operational BIM, thus further increasing the quality of data used for the long-term building operation. To accelerate the building survey and inventory, OrthoGraph supports teamwork functionality. With a well-planned and managed survey work, the speed of work can be multiplied with the number of surveyors doing the work on site. Operational BIM is not only a one-time data source of operation, it's available during the total building lifecycle. If it's properly built into the operational workflows, then it also ensures that all building knowledge will flawlessly be stored in a central BIM instead of storing it in the heads of the maintenance crew. During the time of having a high fluctuation of the maintenance workers, this highly reduces all risks of building operation. So as we saw, importing an existing model into Operational BIM is very well supported by OrthoGraph, but rarely has any benefits compared to the capturing it from scratch. Accurate data and detailed asset inventory is crucial for effective building operation. And that's something that can only be captured on site, going through the building and controlled digitally. Certainly, existing plans can provide additional data source to the captured model, which should be added manually to the accurate BIM. The final results will become a part of the everyday operational work that also ensures that the building will never be required to be surveyed again. The regular maintenance crew can keep it updated effortlessly as part of their normal work. Sign up to this channel and hit the bell icon to get notified about all the new content released related to the world of building operation based on real-life data.